Hello everyone, welcome back to the online class of physics, class 10. So we were learning about, we are learning chapter number 12, electricity, and there we were learning about the resistance, means combination of resistance, series and parallel. So here I have one question ready. So previously we studied about the formulas of the series combination and the parallel combination. In series combination, the total resistance is given by R equivalent or R total equal to R1 plus R2 plus R3 plus R4 and so on. And for parallel combination, the total resistance of the combination is given by 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, like this. So we will just see how to use these formulas or where to implement them. So I have a question here. Three resistance 6 ohm, 2 ohm and 3 ohm are connected to a battery having 6 volt. Find the total resistance and current when they are connected in number 1 series and number 2 parallel. Now here the question it is said that 3 resistance are there of some value. Those are connected to a battery which is of 6 volt. And here we have to find the total resistance of the combination and the current flowing through the circuit. So first we will do for the number 1, that is for the series combination. Series. So in series we will see, first we will write what things are given. So given R1 is equal to 6 ohm, R2 equal to 2 ohm, R3 equal to 3 ohm. So the total resistance, that is R equivalent, is equal to R1 plus R2 plus R3, and here R1 is given as 6, R2 is 2 and R3 is 3, and totally we get 11 ohm. This is the total resistance of the circuit, which is 11 ohm. Now we have to find the current through the circuit, and the voltage given is 6 volt. So we know from the Ohm's law, we know V equal to IR, or we can write like I equal to V by R. So here we got the total value of resistance, that is 11 ohm. So I, that means current, is equal to the voltage given. The voltage is 6 volt, which is provided in the question. So 6 volt by the resistance, means the total resistance we got, that is 11 ohm. This is 11 ohm, and we will divide. Remember one thing, whenever we have to find current, don't keep the value in fraction. If it gets completely divided, divide it fully, and if it does not, then divide it in decimal point, and up to 2 places of decimal will be enough. So here we will divide 6 by 11, so this will be 11, 0, then 60, 11 is 55, and 50, 11, 4 is 44, which is ampere. I equal to 0.54 ampere. You can write it down. Now we will analyze the second part of the question, that is the parallel part. So I am just changing here. So we will see the second part, that is parallel. So R1, R2 and R3 was already given. parallel combination, the total resistance is given by 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, and then we will substitute the values provided. 6, 2 and 3, we will take the LCM, and the LCM for that is 6. So 1 plus 3 plus 2. So totally ohm. Just copy this part. This side I am continuing there. This one I am continuing taking here. So 1 by R is equal to 1 plus 3 plus 2, which is 6 by 6 ohm. So this is 1 by 1 ohm. Now see one thing, just remember one thing. Here we have the value is equal to 1 by R. So here I am getting 1, so that is okay, it will be 1. But sometimes, means here the total resistance will be R equal to 1 ohm. But sometimes what happens, the resistance means 1 by R can come like 2 by 3, for example. Then we have to inverse this. It was 1 by R, so we will inverse equal to R. So as I have inversed it, this will also get inversed. 3 by 2, it will become like this. Then we will divide whatever the value comes. Here it directly came 1, so it's okay for now. And now we have to find the current. I equal to V by R. V was our 6 volt, and the total resistance which came is 1. 6 volt by 1 ohm, which gives us 6 ampere. This is how we have to utilize the values provided. You can write it down.